Hello everyone, my name is Sarah Scannell and I will be explaining what comparative effectiveness is and how to conduct a comparative effectiveness analysis. So what is comparative effectiveness? Comparative effectiveness is an analysis tool used to compare data points to determine which is more effective. To put it simply, it helps you to make a decision between alternatives. For this process, you must first determine a control of each data point. Once your control has been determined, you can then compare each data point to other data points and sets to aid in your decision-making process. For this specific lesson, I will be showing you how to conduct a comparative effectiveness analysis using a decision tree. For those who may not know what a decision tree is, it is a diagram that uses probability of events to determine outcomes. I will first go over the different parts of a decision tree. So in a decision tree, everything stems from a decision node. These are represented by small shapes that have two connecting lines. One thing to note is that if the shape of the decision node is square, the decision is not left to chance. If it is represented by a circle, which is what we have here, then the decision is left to chance. Each of the connecting lines represent the two possible events that can occur from the decision. The line that is labeled represents the event if it should occur. The one below it, stemming from the same node, represents the event if it does not occur. The decimal places that you see represent the probability of that event occurring. The last thing to note are the consequences, which are the last thing to the right of the events and nodes. This shows what happens if a series of events follows a particular path. That is why there are different consequences for each series of events. As previously stated, we must first determine what our controls are to begin the analysis process. To do this, we will need to figure out the average length of stay for each physician above. One average for Dr. Smith and another average for Dr. Jones. To do this, you will need to start from the end, which are the consequences, and work your way back. Let's start by taking a look at Dr. Smith's decision tree. Let's take the first consequence at the top. It says 4.5 days, and if you follow backwards, you will see that we reach the probability for the preceding event. It is represented by 0.15. You will need to multiply each consequence by the probability for each event, then sum them up before moving to the next node. So as you can see, the first calculation we have is 4.5 times 0.15, which equals 0.675. We have just calculated the answer for if a patient has CHF. Now we must calculate for if the patient does not have CHF. To do this, you have to start by calculating the values for BP less than 90. To do this, you take 5 days, multiply it by 0.7, you then take 4 days, multiply it by 0.3. You may ask where I got the 0.3 from. To calculate the probability of an event that is not stated, you simply take 1 and subtract the probability of the corresponding event. So in this case, it's 70% chance of the event happening and 30% chance of it not happening. You add these two up and then you have one more step to go. You now have to take 4.7 that you just calculated, multiply it by 0.85, keep following the same pattern until you reach the end of the tree, and you will have your average length of stay for Dr. Smith. Complete this for both trees, and you should have 3.58 days for Dr. Smith and 4.67 days for Dr. Jones. You are now ready to compare physicians. To do this, we will answer two questions. What is the expected length of stay for Dr. Smith if he were to take care of patients of Dr. Jones? And what is the expected length of stay for Dr. Jones if he were to take care of patients of Dr. Smith? To answer these questions, we have to take the consequences of each physician and swap decision tree events. If you look at the diagram on the right, you will see Dr. Smith's consequences on Dr. Jones' tree on the right side, and Dr. Jones' consequences on Dr. Smith's tree on the left side. You may notice some changes in the events of the tree. Since there were additional events in Dr. Jones' tree that were not in Dr. Smith's, we must use Dr. Jones' data in the comparison. But please note that since there was not any data for Dr. Smith on those same data points, we must eliminate them from his comparison. Following the same pattern of calculating used to get our initial averages, you can conclude that the average length of stay of Dr. Smith taking care of Dr. Jones' patients is 4.87 days, and the average length of stay of Dr. Jones taking care of Dr. Smith's patients is 3.64 days. So in conclusion, you can see that Dr. Smith was less effective than Dr. Jones when taking care of Dr. Jones' patients, but Dr. Jones was more effective when he was taking care of Dr. Smith's patients.